Now, alright guys, the question for question 3 is, it says, using the identity cos 4 theta plus I sin 4 theta equals cos theta plus I sin theta to the power 4, show that. Now, they don't have to give you that in an exam, so what I'm trying to prepare you for is, what happens if they don't give you that start off? Here's how you identify it. See the way it has a 4 theta here? See the 4 theta there and the 4 theta there? That straight away should tell you that you're using power of 4. If it was 5 theta, what would you use? You'd use power of 5. Okay? And then, and so forth, right? So what's this? Okay, and yeah, equals cos 4 theta plus I sin 4 theta. Now, does anybody remember something called the binomial expansion? Exercise 1.8 in 5th year. Anybody care to explain to me what it is? If I gave you something like this, and I said to the power of 6, what does that actually mean? I'm going to have to multiply this out 6 times. Have you ever gone above 3 before? No. Anything above 3 takes too long. This is telling us to do this 6 times. And you're like, not a chance am I doing that 6 times. Alright? So we have something called the binomial expansion, okay? And the binomial expansion works like this. You go to your first power, what do you see? 4. Alright? 4c0. First one to the power of 4. What's the next one? 4c1. First part to the power of 3, second part to the power of 1. Next part after that? 4c2. And what happens there? First one to the power of? Second one to the power of 2. Alright, just going to make my writing a bit less gigantic. If I can. There we go. Alright, second one to the power of 2. Right, what's after that then? 4c3. First one to the power of 1. Second one to the power of 3. And finally the last part. 4c4. Second one to the power of 4. The key thing to realise is that because this is a power of 4, everybody see it's power of 4? It means that the powers always have to add up to 4. No matter what, they have to add up to 4. Is that okay? Now, next part to this question, okay? What we're going to do next is the following. We're going to put in our numbers, okay? So, what do we have here? Cos theta, is it? Cos theta, I sin theta, I sin theta, cos theta, I sin theta, and then I sin theta to the power of 4. Alright, now, alright, 4c0, anybody? 1. 4c1, 4. 4c2, 6. 4c3, 4. 4c4, 1. It's symmetrical, isn't it? 1, 4, 6, 4, 1. First one is cos squared, oh sorry, not cos squared 4, cos to the power of 4. So, cos theta to the power of 4. Next one, anybody? 4. What's significant about every second one? It's going to be real, imaginary, real, imaginary, real. So this has an I in it, doesn't it? So it's 4i cos cubed theta sine theta. Is that okay? Now, can anybody tell me what's I sine theta squared? I squared sine squared theta. And what's I squared sine squared theta? Minus, isn't it? So this one here is going to be minus 6 cos squared theta sine squared theta. Everybody sees the way it has no I in it. Is that correct? So it's going to be no I, no I. Now what about the next one, lads? It's got to have an I in it, isn't it? And what's the number we're using? 4c3 is 4. Anybody tell me what's I cubed sine squared cubed? Or sorry, sine cubed theta. What's I cubed sine cubed theta? Minus I sine cubed theta. Okay? So this is going to be minus 4I cos theta sine cubed theta. You all okay with that? Ben, show them after you drink. Now what's next? What's I to the power of 4 sine 4 theta to the power of 4? What's I to the power of 4? I squared. Squared. And what's I squared squared? It's minus 1 squared. And what's minus 1 squared? Just 1. Okay. So that is just going to be sine power of 4 theta. Now, here comes the interesting part. I'm going to grab all that there. I'm going to group it. Make it just that little bit smaller. Now, what did we just expanded the Myers term, didn't we? That was the Myers term, and we expanded it out. Okay? Will you throw off the lights, Fallon? Okay. Okay. That was the Myers term, and we expanded it out. But what was it on the other side? It was cos 4 theta I sine 4 theta. So cos 4 theta now this all comes back to something as simple as this. If I said a plus bi is 3 plus 4i, what's a and what's b? A is 3, b is 4. You match the real with the real and the imaginary with the imaginary. So let's start off with the real parts. Which part is real on the left? Yeah, and on the right? And? Everybody cool with those three? So what equation can I make out of this? I can make cos 4 theta equals, anybody? Oh, sorry, keep doing that. Cos to the power of 4 theta minus 6 cos squared theta sine squared theta plus sine to the power of 4 theta. Is that okay with you guys? Alright, Connor, what would be the next equation then, the imaginary one?
I sine 4 theta.
No need with the i's. The i's will all cancel anyway, so what do you reckon? Sine 4 theta equals? 4 cos cube theta, yeah? Sine theta?
4 cos theta sine cube theta.
Is that what the question's asked me for? I'm hoping it isn't. Go back to the top. Alright. The second answer is correct. Would you agree with that? Is everybody happy that the sine theta is correct? Everybody see that? That one's correct. What's the problem with the first answer? There's no sines. Sines aren't allowed. So go back down. So this answer is perfect, and this answer is currently not accepted. Everybody cool with that? Alright. So, suggestions, lads. Anybody got anything for me? Now what does it want from us? It wants us to have 8 cos theta to the power of 4 minus. So there's no There's no signs allowed. Okay.
Since it's sine squared, could you do the matrix from the table?
I'm going to do this.
Or how can the bottom of that?
There's nothing to do on the sine 4 theta one, you mean?
Yeah.
Yeah, I just checked my answer with the original equation. This one, they're happy with this one, but they're not happy with this one, so I have to change it. They didn't match up, is essentially what happens. Now, I'm noticing there's no sine thetas here. So what I'm doing is I'm creating a rule to get rid of the sine thetas for myself, right? So what's this going to be then? Anybody? Sine squared theta equals 1 minus what? Cos 1 minus cos squared theta. Is that alright with you guys? What happens if I square both sides? Square both sides. What happens then? So I'm going to square sine theta. What happens if I square this by itself and this by itself? What happens then? Sine 4 theta. Everybody got that? And then what's on this side? 1 minus theta plus. Everybody cool with that? Right. Let's sub this stuff in and see what happens. So this is going to be cos to the power of 4 theta minus 6 cos squared theta into 1 minus cos squared theta. And what about over the other side? What am I changing this with? All that, isn't it? These questions are long, but eventually they become really easy because they never change. Sorry, I run out of space there. But look, here's the gist. Right? What's minus 6 cos squared theta by cos squared theta? Anybody? Huh? 6 cos 4 theta. And what's 6 cos 4 theta plus the other two? Anybody? 8 cos 4 theta. And minus 6 cos squared theta. And what else is over here? Minus 2 cos squared theta plus 1. We're very close to the answer now. And what's the answer? Anybody? 8 cos 4 theta minus. Yeah. And then plus 1. We're done. Alright. Lads. Tell me something. What's 2 multiplied by 2 multiplied by 2? Huh? 8, isn't it? Would everybody agree that's one of the answers? Z equals 2. Would I get any marks for that? Why? It specifically says use the Myers theorem. Okay? Anybody know how to get the second one? Second answer. Actually saw it out already. What's minus 2y multiplied by minus 2y multiplied by minus 2y? Anybody? Minus 8i cubed. Actually, that doesn't work. So I only got one answer. Is that alright? So, here's what you're going to do. You have to present 8. You have to present 8 in polar form. You can only use the Myers theorem and what happens? Huh? When it's in polar form. Okay? So here's what we're going to do. R cos theta plus I sine theta to the power of n equals what? Anybody? R to the n, and then after that cos n theta plus. Alright, great. Let's start off with the number 8. What is 8? Would everybody say it's 8 plus 0y? Would everybody then say it's 8 into 1 plus 0y? Are we on board so far? 1 plus 0y. Okay. Next part. Draw 1 plus I on your Argand diagram. Oh, sorry. Right. So let's do that really quickly. Where's it located? One across, isn't it? The distance would be 8, but we took the 8 out. Okay. What angle would make that work?
0.
Huh? 0 would make it work. So you could say it's 8 cos 0 plus I sine 0. Anybody care to tell me what might be a fault in that one? It's always going to be 0, isn't it? Does that make sense? When you multiply in by n, it's going to be n times 0, n times 0. You're not going to get any different answers, are you? No matter what value of n you put in. Can anybody give me an alternate answer that might work just as well?
2 pi.
Would everybody be alright with 2 pi? 2 pi do the job? Okay. So, won't go for that, we'll go for 2 pi. You could also go for 4 pi by that logic, couldn't you? But I think we're going for the first non-zero answer right there, right? So is everybody happy I converted that complex number into polar form? Okay. Now what's the original question? Is the original question not z cubed equals that? Okay. Now, can anybody care to tell me what would be a suitable idea here? What would you do if you had x cubed equals 8? What would you do there? Cube root is otherwise known as to the power of third. So would everybody be happy using the same logic I used on the bottom left of my screen? Would everybody be happy if I just wrapped the complex number on the right to the power of a third? Is that okay with you guys? Now, what happens next? Okay, so you cube root the a, and what happens when you cube root the a? 2. I'm about to make an error, right? Just to make you aware that there is an error coming, right? And I want you to know why it's an error. Okay? That's the real skill is knowing you've made a mistake, okay? So it'll look like I've done nothing wrong. Okay? So what happens next? Cos 2 pi over anybody? 3. Okay, and then after that? So 2 pi over 3. Okay? Nothing wrong with that. Okay? So what happens when I put in 2 pi over 3 into my calculator? What you get? What is it? Minus a half, yeah, no bother. So you're saying that's 2 times minus a half, is it?
Yeah.
Okay, and then over here? Okay. Got to multiply it out, and what do I get? Minus 1 plus root 3. Is that cool with you guys? Really quickly, how could I check that answer?
Should be minus 1 plus root 3i.
Oh, root 3i, sorry, my fault, yeah. That's actually not the mistake I was looking for, but that's perfect as well. Alright. Really quickly, how would you check that that answer is a valid answer? If you were to multiply that out by itself 3 times, I guarantee you get 8. It's a good answer. You can check the back of the book if you want. That is a good answer. What's the problem though? I need 3 answers. How many answers do I have? 1. Right? So there's something we're missing out on here. Okay? And here's the key part, right? So we did nothing wrong there. That is a perfectly valid answer. But here's the key parts. What happens when we learned back in the day is that when we did the 4 quadrants, okay? Let's say for argument's sake an angle of 30. What's the next value that's the same as 30? Anybody? Huh? 390. What happens after that? Anybody else? Yeah. Now we didn't start off with 30, did we? What did we start off with? Technically 360. What's the next one that's the same as it? What's the next one that's the same as that? Now, really want you to clue in here. Do you see the way it's set to the power of 3? That means you should take 3 rotations into consideration. If that was set to the power of 5, how many rotations should you take into consideration? Perfect. Alright. Now, you're going to go back up here and you're going to fix the 2 pi. See the 2 pi? And instead of using 2 pi, you're going to use 2n pi. I'll make the n really big. And what does the n stand for? How many rotations you're using. We already know one of the answers, don't we? We knew z equals 2 was an answer at the very beginning of the question. If I don't get z equals 2, something's wrong. Let's go through this now. Okay? So what happens when n equals 1? What's the answer? I think it's the one we got earlier, wasn't it? It's the answer we got earlier, which was 2 times cos 2 pi over 3 plus I sine 2 pi over 3. So 2 pi over 3 is the angle. Just the angle part, okay? And what did we say that was earlier? It was minus 1 plus root 3 I. Happy days. Next, try n equals 2. What happens when we do n equals 2? What do we get instead? So minus 1 plus 3i is the first answer. So what happens when it's n equals 2, lads? What's it going to be this time? It's going to be 4 pi over 3, isn't it? So it's going to be cos 4 pi over 3 and I sine 4 pi over 3. Okay. What's the answer this time? What's 2 times cos 4 pi over 3? And what's 2 times sine 4 pi over 3? Really quickly. So minus a half and? So what's this answer going to be, Mick? Minus 1. Sorry lads, just stick with me 1 second. Last one, we're going to use n equals 3. And this time we're going to have 6 pi over 3. And we're going to have 6 pi over 3 and 6 pi over 3 and sine 4 pi over 3. And we both know they're 2 pi, don't we? And what's cos 2 pi? 1. 2 times 1? 2. The answer we were expecting. Alright, for tonight, I'd like us to do questions. I'll post this up right now, right? So I want you to do questions 2, 3, 4, 7 and 8. Exercise 1.10.